Hi everyone. Today we're continuing chapter 6 and we're going to discuss how to name and write ionic formulas. So as an example, if you use table salt at home, you might have noticed that the packaging says that the salt is iodized. That just means that there is added iodide ions to your salt. And the reason for that is iodide ions are good for your thyroid. You can buy salt without iodide ions in it, but again, the iodide ions are there for your health and well-being. So what's actually added to the salt is something called potassium iodide, which is an ionic compound. And the chemical formula for potassium iodide is Ki. So K standing for potassium and I standing for iodide. All right, so when you're naming an ionic compound, we're going to write the name of the metal first. And we're not going to change the name of the metal, it's just going to stay the same. So, for example, we just talked about Ki, and we start by naming the metal, which is potassium. Then we're going to add the name of the nonmetal, except we're only going to use the first syllable of the nonmetal. And then we're going to add IDE on the end. So this would be potassium iodide. So iode is the first syllable of iodine, and then IDE is added at the end. And then we do leave a little space in between the metal and the nonmetal. Okay, so I'm also going to write this in a slightly different way than the instructions show. So one good way to remember this, let's draw a box and write metal. And then we write the first syllable of the nonmetal, and we add IDE on the end. So if you're making flashcards, on one side you could write how to name an ionic compound, and on the other side you could write these boxes. And at least that's a little less wordy. All right, so not too bad. So again, we just saw how to name potassium iodide. If we go down in this table that's found in your textbook, we have magnesium bromide. Now, notice that in this particular compound, we have one magnesium ion and two bromide ions. However, we don't have to indicate how many of each ion we have in the name. And that's because we can determine the chemical formula by the charges on magnesium and the bromide ion. So for instance, if you're given the name of the ion first, you can still figure out how many of each ion you should have in the formula based on these charges. So we'll do some example problems with that later on. All right, and then in the last column or row here, we have Al2O3, which is aluminum oxide. So we're just taking, again, the name of the metal, and then we're using the first syllable of the nonmetal and adding IDE on the end. Okay, so let's do a learning check. We're going to write the formulas and names for compounds of the following ions. So on the left-hand side, we have positive ions, so those are metals. We have sodium and aluminum. And then on the top, we have nonmetals, or negative ions, which are bromine, sulfur, and nitrogen. So if you want to pause the video and try to name these molecule or compounds as well as figure out their formulas, you can do so, and then we'll go over it together. Okay. So just a quick side question here. What do we call positive ions? Cations. So remember, cations are positively charged. And then what about negative ions? What do we call those? Anions. So that's just a side note. Okay, so now let's name these compounds. All right, so if sodium teams up with the bromine ion there, what would the formula be? So we have a plus sign and a minus sign, and they balance each other perfectly, so this would be NaBr. So now we have a neutral ionic compound, and how would we name this compound? Sodium bromide. Okay, so let's go across that row. So if we pair sodium with sulfur, what is the chemical formula? So we have a positive charge and a 2 minus charge. So how many sodium ions do we need to balance the charge on sulfur? 2. So this would be Na2S. And I believe we saw this in a previous lecture as well. Okay, so how would we name this compound? So it would be sodium sulfide. Some people use a pH instead of an F for sulfide. That's fine. All right, so now let's say we're pairing up sodium with nitrogen. So we have a positive charge and a 3 minus charge. So what is the formula there? Na3N. So we need 3 sodium ions to balance the charge on the nitrogen ion. And how would we name this ionic compound? Sodium nitride. Okay, so now let's work on row 2. What if we pair aluminum with bromine? What is the formula? So we have a 3 plus charge and then a minus 1 charge. So how many bromine ions do we need to balance the charge on aluminum? 3. So we have AlBr3. And how do we name this compound? So again, we just named the metal like we normally would, so aluminum. And then the nonmetal we already saw above is bromide in its ionic form. All right, so let's say we're going to pair aluminum with sulfur. This one's a little tricky. So we have a 3 plus charge and a 2 minus charge. So what is the formula? So remember from last time, we talked about how you can just switch the charges and make them subscripts. So we're going to need 2 aluminum ions and 3 sulfur ions to balance each other out. And if you need to draw pictures to figure that out, that's totally fine, because if you're more of a visual learner, that can help. Okay, so then how do we name this compound? So again, we have aluminum, and up above we saw that we would name the nonmetal ion sulfide. All right, and then last but not least, what if we pair up aluminum with nitrogen? What is the formula? So this one's super easy because the charges are equal but opposite. We have a 3 plus charge and a 3 minus charge. So we just have one of each ion. And then how do we name this one? Aluminum nitride. Okay, so hopefully that helps to kind of get a feel for how to write chemical formulas for ionic compounds, and then also how to name those compounds. And here are the solution slides if you want to practice this later. Now, unfortunately, not all metal ions have predictable charge. So we did talk about how groups 1, 2, and 3, those metals have predictable charge that never changes. However, there are metals, such as the transition metals, that do have variable charge, with a couple of exceptions. So, for instance, if we look at the transition metals on our periodic table, the majority of them have multiple charges that they could potentially possess, depending on what they're bonded to. However, zinc, cadmium, and silver, they have only one charge state, we call it. So zinc is always 2 plus in its ionic form. Cadmium always has a 2 plus charge in its ionic form, and silver always has a +1 charge in its ionic form. But most of the other transition metals are going to have multiple charges depending on what they're bonded to. So how do we indicate that in the name? Because we should indicate what the charge is. That's going to have a huge effect on the chemical formula for a compound. So what we do is we write a Roman numeral equal to the ion charge. And we put that in parentheses right after the metal name. So a few examples are given below. We have copper, and copper can either have a +1 charge or a +2 charge. So the way that we differentiate those is, again, with Roman numerals in parentheses. So you'll notice that the 2 plus ion for copper has a Roman numeral 2 in parentheses, and the +1 ion has a Roman numeral 1 in parentheses. Iron can have a 2 plus charge or a 3 plus charge, so you'll notice we've added that next to the name. Lead is not in the transition elements, but this is one of the exceptions for the representative elements. So lead can have multiple charges. Lead can either have a 2 plus charge or a 4 plus charge. So we're going to indicate that next to the name. And then chromium can have a 2 plus charge or a 3 plus charge. So if you're a little rusty on your Roman numerals, I'll just write a little chart down below. All right, so 1 is just a 1. 2, we write 2 lines. 3, we write 3. 4 is a little tricky. So 5 is represented by a V. So 4, we're going to put a 1 in front of the V, and that indicates we have 1 less than 5. So 4 is a little weird. 6, we're going to put a 1 after Roman numeral 5. 7, we're going to put 2 lines after Roman numeral 5, 8. Let's see, 10 is an X, and 9 is a 1 in front of the X. Okay. Now, we're not really going to deal with charges that large, so don't worry too much about that. I would say to focus on these first 5 Roman numerals. Those are the ones that we'll see the most often. All right. So in your textbook, there's table 6.6, and this shows a lot of different examples of transition metals with different charges. So, for instance, let's see, bismuth is an interesting one. So, bismuth is actually what's in Pepto-Bismol. And it's only a little bit of bismuth that's in Pepto-Bismol, but that's kind of where it gets its name. And bismuth can have either a 3+ charge or a 5+ charge, which is really interesting. So you'll notice that the, oh, I thought that was my highlighter. So you'll notice that the charges are listed right next to the metal name. And then we talked about a few of these other metals as well. So just keep in mind that naming ionic compounds with one of these metals is going to be a little bit different. And here's a nice periodic table summarizing all of these different charges we've talked about. So again, in groups 1 and 2, we have predictable charges. So everything in group 1 has a +1 charge, everything in group 2 has a 2+ charge. And then when we look at groups 3A through 8A, we do have aluminum in group 3A, which has a predictable charge. And then the nonmetals here also have a predictable charge. So we talked about how to figure that out. You can just take 8 minus the group number, and that will give you the negative charge on the nonmetal. But notice in the middle of the periodic table, that's where we have most of our variable charges. So chromium, manganese, iron, cobalt, etc. Except for zinc, silver, and cadmium. Those were our 3 transition metals that have predictable charges that are always the same. So I would like you to remember the representative element charges, so groups 1 through 3 and then 5A to 7A. Don't worry too much about the middle of the periodic table because we'll see in a minute that you can figure out the charge on the metal just based on the chemical formula or the name. So for example, let's say we're given a compound, manganese something fluoride. So we don't know the charge on manganese because manganese can have multiple charges, right? However, we can figure out manganese, the manganese charge based on how many fluoride ions it's bonded to in this compound. So we know, if we go back, that fluoride is in group 7A and it always has a -1 charge. Now in this compound, we have 2 fluoride ions, so we have 2 negative charges total. Okay, so we also know that ionic compounds should be neutral. So we know that all of the charges in this ionic compound have to add up to 0. Okay, so now using that, we're just going to try to figure out what is the charge on manganese. Okay, so if we do the math, we would find that manganese has a 2+ charge to balance out the 2 negative charges coming from the fluoride ions. So we would name this manganese 2 fluoride. Okay. Now, another way that I kind of like to do this, if you're more visual, I like to write out what I have. So I have 1 manganese ion and 2 fluoride ions, and I know that each of the fluoride ions are negatively charged. So that gives me a total of -2. And I know that manganese has to balance that charge, so it must be +2. And that's another way that you could try to figure it out instead of doing a mathematical equation. It just kind of depends on how you best understand the information. Okay, so let's do a practice problem. We're going to name the ionic compound FeCl2. So if you want to try this on your own first, feel free, and when you unpause the video, we'll go over it together. Okay, so we have iron, and we don't know what its charge is, because iron could have multiple different charges, just depending on what it's bonded to. And then we also have 2 chloride ions. And what is the charge on chloride always? So remember, chlorine is in group 7A, so it would have a -1 charge. Okay, so that gives us a total of -2. And we know that everything has to add up to 0. So what must the charge on iron be to balance that -2 charge? +2, right? All right. Now, down below, I wrote this mathematical equation, so we could kind of go through that as well. Okay, so we have question mark plus -2 equals 0. And if we work through that, we would find that the question mark equals +2. All right. And then here are the solution slides if you need that later. Oh, and then the name of the ionic compound. So we said that iron has a 2+ charge. So we would want to name that iron 2 in parentheses chloride. So the 2 is in Roman numerals as well. All right. So now how do we go in the other direction? What if we're given the name and we want to figure out the chemical formula? So the first part of the name, remember, describes the metal ion. And if there's no charge listed next to the metal ion, then we know that it's something with a predictable charge. However, if there is a charge listed in Roman numerals next to the metal, that also tells us the charge, right? And then the second part of the name specifies the nonmetal ion. And then once we know what the metal ion is and what the nonmetal ion is, we're going to add subscripts to the chemical formula to make sure the charges are balanced. So you can see off to the right some ionic compounds. And you'll notice that they're in a couple of them. Let's see. So these first two both contain iron. And the first one contains iron with a 2+ charge, like we just saw. The second compound is rust, Fe2O3, which is iron 3 oxide. So this particular iron ion has a 3 plus charge. So it's important to also place those Roman numerals there because that's going to change your compound. So let's write the formula for iron 3 chloride. Now, we already looked at iron 2 chloride in our previous practice problem. So now let's figure out what iron 3 chloride looks like. Okay, so in the name, we can see we have a 3 plus ion. And then we have chloride. And we already said that chloride has a -1 charge. Okay, so we're trying to figure out the formula. So how many iron ions do we need and how many chloride ions do we need to balance the charges? So we need 1 iron ion and 3 chloride ions. And that will balance our charges. So the formula will be FeCl3. So this is entirely different from FeCl2, which we saw earlier. So again, remember that charge is going to have a huge effect on the chemical formula. So make sure to include those Roman numerals in your name if you have a transition metal with variable charge. All right, let's do one more practice problem. Let's write the chemical formulas for the following compounds: nickel 2 sulfide, zinc chloride, and iron 3 oxide. And if you want to pause the video first and try this on your own, feel free. Okay, so let's start with nickel 2 sulfide. Okay, so we're told that nickel has a 2 plus charge. And then sulfide, what's the charge on sulfide? So which group is sulfur in? So sulfur is in group 6A. So 8 minus 6 equals 2. So sulfide has a 2 minus charge. Okay, so then how many of each ion do we need to make a neutral compound? Just one of each, right? NiS. So that 2 plus charge is balancing out the 2 minus charge. Okay, now for B, zinc chloride. Now remember, zinc is one of those transition elements that just has one charge state, and that is 2 plus. So zinc always has a 2 plus charge in its ionic form. What about chlorine? What did we say the charge on chlorine was? -1. Okay, so how many of each ion do we need to balance those charges? So we need 1 zinc ion and 2 chloride ions. And here I'll put boxes around the answers. And now for C, iron 3 oxide. So we have an iron ion with a 3 plus charge, and then oxygen. So what is the charge on the oxide ion? What group is oxygen in? So it's also in group 6A, right above sulfur. So 8 minus 6 is 2. So oxygen has a 2 minus charge. Okay, I'm going to make some room here. So then, how would we write the chemical formula here? How many iron ions do we need and how many oxide ions do we need to balance? So remember my little trick, you can just switch the charges and make them subscripts. So we need 2 iron ions and 3 oxygen ions or oxide ions. Fe2O3, and that's also known as rust. Okay. And then here are the solution slides if you need those later. So next time, we're going to talk about a very specific type of ion called a polyatomic ion. So these are ions that are actually a group of elements bonded together that have an overall charge. So we'll talk about that next time.